Now that we've already talked about some of the ways that arguments are presented, it's also important to talk about the strategies, that are used to go through the process of reasoning. The first way or the first strategy of reasoning is that of induction. And what induction is where you arrive at a conclusion based on what you judge to be the sufficient evidence that is actually available. So you're basing your information from a very specific amount of information, and then you make a general conclusion as a result. Now, obviously, this isn't an absolute certainty, but let's look at the example that's listed here. So on 10 different occasions, I've eaten seafood. Every single time I've eaten seafood. 10 times I've eaten it, and I've gotten sick. Every time I eat seafood, I get sick. Those are very specific instances. I got sick at Aunt Judy's house when I had the shrimp cocktail. I got sick at Uncle Jim's house when they had the crab salad. When I went to Baltimore, for our summer vacation, and we had seafood, I was sick. When I went to my best friend's graduation party and someone made these delicious crab cakes, and boy were they tasty, I got sick. These were all very specific instances. So, as a result of that, the logical person who's going through this process of reasoning would make the statement that seafood makes me ill. Don't touch the seafood. And that's what induction is, where you're going from specific instances and moving to a general conclusion as a result. Think of when you have a scientific experiment that you've conducted 10 different trials of it, and then as a result you come up with a general conclusion based on those 10 different trials. Now, inductive arguments can include any of these ideas as well, where you're going apart to whole, where the whole is assumed to be like all of the individual parts. So if you find two ragged edges of something, and you know that they both go to some larger piece, and your assumption is going to be that the whole piece has ragged edges. It's just bigger. That's all. It can also be extrapolations where areas beyond the area study are assumed to be like the area that's being studied currently. So if you have a species of fish that are caught and are studied at an aquarium for their movement and mating rituals, so to speak, then you would make an assumption that all fish who are in that category would act the same way. Now, obviously, there are some issues with that, but we do it all the time, where we have these predictions where the future is going to be assumed to be just like the past based on specific instances. There are numerous times when athletes are compared to athletes in the past based on how they have acted, and then there are assumptions made that they're going to be like so-and-so because they show similar characteristics to someone else. Another good example is here when we take a look at a motorcycle and its maintenance properties. So if a cycle goes over a bump and the engine misfires, and then goes over another bump and the engine misfires, and then goes over another bump and the engine misfires, and then goes over a fourth bump and the engine misfires again, well, one can logically conclude that the misfiring is caused by the bumps. Every single time I've gone over something, my car misfires. So that means, number one, I'm not going to go over any more bumps, or I'm going to try to avoid them as much as possible because I've made the conclusion that the bumps are causing the misfire. Specific instances, and I drew a general conclusion. And that's what induction is, when you go from particular experiences to general truths. Okay. Some of you may also be saying, okay, well, I don't drive a motorcycle. I don't know what you're talking about, Ms. Bond. Think of it like this. Every time, I didn't do my homework last night. And when I got to class, I didn't know what was going on. Last week, I forgot to do my homework one time. And of course, that's the day that Ms. Bond decided to go over it. And I didn't know what was going on when she was talking about whatever it is that she was talking about. 2 weeks ago, I didn't do my homework for an entire week. The entire week, I had no clue as to what was going on. What can you logically conclude as a result of those specific instances? Right, that you need to do your homework, because not doing my homework is going to mean that I'm not going to understand what's going on in class. And yes, I did do this one on purpose because it's type of inductive reasoning. I told you this class affects other areas of your life. You gotta love rhetoric. Okay, so that's inductive. When you're moving from specific to general, you have specific instances that you draw a conclusion from. And that conclusion is very, very general. Okay, so what we've covered so far is one strategy of reasoning. And this time, the strategy was induction. Now, do you remember how we would define induction? What the movement is like? Well, if you don't remember, in inductive reasoning, you're going from specific instances. So specific instance number 1, specific instance number 2, specific instance number 3, 4, 5, and let's throw in specific instance number 6, just for good measure. Based on all those things happening each time that something's occurred, the same thing happens. So, as a result, I'm going to end up with a general conclusion. And that general conclusion relates directly back to each one of those specific instances. Yeah. So, if you have any questions about inductive reasoning, make sure you come to class with them tomorrow with them. We're going to be doing some activities that talk about inductive reasoning so that you can get a little bit more practice in seeing how that plays out in real life. Next, we're going to be talking about the second strategy of logical reasoning, and that is called deduction. So, make sure you check that one out next. Okay, Ms. Bond signing out.